All right, so this is the video lesson for my IM2 robotics and computing class, and we're talking about independent versus dependent events. We spent some time in class today talking about it, but I really wanted to make sure I drove the point home with you guys because this would be something that's going to be huge on the unit test coming up. So let's first talk about independent events. So as you can see here, I pulled this slide. And I really like how it's said and how it's framed, so I decided to use it. Events can be independent, meaning each event is not affected by any other events. Okay? The perfect example we can think of independent is tossing a coin. Okay? As it says, each toss of a coin is a perfectly isolated thing. What it did in the past will not affect the current toss. Meaning, if I flipped a quarter and it says heads, it's not like the quarter remembers and says, oh, I have to be equal and do tails next, right? It's always a equal chance it will be heads or it will be tails, because the coin doesn't remember, and because I flipped a heads the first time doesn't mean I'm more likely to get tails the next time. It's always a 50-50 chance. In fact, I think there was something on your pre-test about this. Okay, so each coin toss is an independent event, meaning if I toss it once, the second time I do it, it doesn't change the outcome. Okay, so for example. Okay, if I flip the coin 7 times, okay, and they say it's unlikely to get 7 heads in a row when each toss has a 50-50 chance or a 1 in 2 chance. So think about it. Why, if it's always a 1 in 2 chance, why is it so rare to get 7 heads in a row? Well, if you're predicting that you're trying to get 7 heads in a row, the odds of that happening are very slim, okay? Because what you do, as you see, is that you have to multiply your chances 1 and 2 7 times. So 1/2 times 1/2 times 1/2 times 1/2 times 1/2 gives you 0.0078125, which is less than 1% if you made it a percentage. Okay? Okay, but so the probability of getting 7 heads in a row is that small. But look at question 2 here. Given we have just got 6 heads, okay, what's the probability that the next toss will also be a head? Okay? Because they're independent, because like we just talked about, if I flip a coin, it doesn't matter what the past 100 coin flips were. The 101st time, it's still going to be a 1 out of 2 chance, because I have 2 sides of a coin, and to get heads, I have 1 out of 2 chance. It doesn't matter what all the other coin tosses have been, because the coin doesn't know. The coin doesn't like say, ooh, let me try to fool you and do something tricky. So the coin is always going to be fair, and it's always going to be a 50-50 chance no matter how many times you flipped the coin. Okay? So that is a good example of independent events. So another good example of independent would be if I draw something. Okay? So, I mean, if I'm drawing cards out of a deck. Okay? So if I draw I want to draw a king, then a diamond. Okay? But these are 2 separate events, and I also have to tell you that I'm going to replace the card after I draw the first time. So the probability of drawing a king first. Okay, let's talk about that. So there's 4 kings in a deck, and there are 52 cards in a standard deck. Okay. Then, if I replace the card, meaning I have 52 cards still, getting a diamond. Well, there are 13 diamonds inside of a deck. So I just multiply them together, right? Because I replaced the card, drawing a diamond had no difference, right? It's just like I draw a king, okay, put the card back, draw a diamond. But the chance of that happening, 13 times 4 is 52. And then 52 times 52, okay. Well, actually, let's do this. Let me show you some tricky, fancy math here. So we can actually cross-reduce, if we can, which is always smart. 13 goes in the 52 4 times. 4 goes in the 52 13 times, which means I have a 1 out of 52 chance of drawing a king, then a diamond. Okay, 1 out of 52 chance. All right, anyway, so there's some fancy math. But notice the key word here is that I replaced the king. So whenever I have a replacement, meaning I do one action or one event, that I put the card back, or I put the marble back, or I put something back, then do it again, the second time I do something, event B, it doesn't affect it. So what I'm getting at here is this. If we replace marbles in a bag each time, then the chances do not change, or replace cards in a deck each time. So with replacement, the events are independent. They don't change. And now let's talk about without replacement. These are dependent. Okay? So if I were to have marbles in a bag, okay, let's talk about that for a second. And this is the scenario I'll give you. Okay, I have 2 blue and 3 red marbles in a bag, which are these marbles right here. Okay, so it's those guys. All right, what are the chances of getting a blue marble? Okay, meaning I want to draw a blue marble. I have a 2 in 5 chance of getting a blue marble, right? Because I had 5 marbles total, and 2 of them are blue. Okay, but after taking one out, it changes. Okay, so now if I take that blue marble and don't replace it, okay, here I'll get a black marker here and exit out, okay. Notice how I only have 4 marbles. I have 3 red and 1 blue, okay. I have 3 red and 1 blue if I draw a blue marble, okay. So look at this bottom scenario right here. If we got a blue marble before, then the chance of getting another blue marble is 1 in 4, right? Because I only have 1 blue marble left out of 4. Okay, but let's say I got a red marble the first time, okay. Let's say when I drew, I got a red marble, meaning I would take out one of them here. My chances of getting a blue marble the next time would be 2 out of 4, right here, 2 out of 4. So because I take the marble out and I don't put it back, the total number of possibilities or options I had have changed. So the first time I had 5, but both of these scenarios I only have 4 marbles left. So it's dependent because when you take one out and don't replace it, it changes the chances of the second event. Okay? So that's kind of the difference between independent and dependent. You have to be able to recognize the difference between them, whether or not, like if I do one thing and then another, so if I do event A and then do event B, is event B affected by what happened in event A? And so typically it's because I didn't replace a marble, I didn't put back the card, but something like a coin flip, or if I do replace them, it won't change it at all. But if I change the number of items I have, like marbles or cards, then it will change what I get for event B, okay? So that kind of gives you a general description of what I want. Make sure you do the quiz on the bottom, and hopefully this was helpful.